All right, so before we start lesson, Mr. Cole already asked whether you have already learned attempted the lesson 1, lesson 2 in the 88 tuition. And then instructions: answer all questions, type your answers in a given line. The use of calculators is allowed, or I won't say it's allowed, it will help you to calculate faster. So do you have a calculator with you?
No.
So
Yes.
please go and get hold of your calculator, unlock if you haven't got your calculator yet.
I have a calculator, but I do not have it with me right now.
Yeah, so later, unless you are very good mentally, you can do your mental calculation. All right, never mind if it is quite inconvenient to find your calculator. Let's continue. So recap. What exactly is a prime number? Since you already go through with your teacher, or teacher has already gone through this with you. A prime number is a whole number that has exactly two different factors, one in itself. So every time when you come across this type of sentence, the next question that people will ask or people will test you is one a prime number?
No.
1 is neither a composite or a prime number because to be a prime number, it can only be divided by uh itself and 1 and must have exactly two different factors. But uh while 1 can be divided by 1 and itself, which just makes it one factor, which does not fit the prime number. Composite number, it is not composite number either because composite number require more than two factors, whereas just like I said before, 1 only has 1.
Wonderful. Okay, unlike you got your facts so clearly stated. All right, so that goes to the next one, which is a prime number. It's a whole number that has more than two different factors. So it has to be more than two different factors. Then, of course, the next thing that you need to learn about is prime factorization. That's the reason why you learn prime number, so that you can identify what is a prime number and you go on to prime factorization. What is prime factorization? A process of expressing a composite number as a product of its prime factors. So it has to be prime factors. Then after that, today's session, we will also cover highest common factor. Though you're already done in primary school, now we specifically will focus on prime factorization and then also lowest common multiple. All right, so let's go on to the next slide. Okay, now I go on to this slide that says, what is index notation? Now, it is a mathematical notation to represent the operation number multiplying by itself repeatedly. So if any number multiplying by itself repeatedly, we can express it in index notation. In this case, the base is a 3 and the index is a 4. So it can be read as 3 to the power of 4. All right, so if you continue to see that, interesting notes is that if we have 3 to the power of 4, that gives you 81. So if it's 3 to the power of 3, that gives you 27. Now, sometimes 3 to the power of 3, you also call it 3 cubed. Okay, so I go on. What about 3 squared? Obviously, 3 squared will be 3 times 3, and that gives you a 9. What about 3 to the power of 1? Anyone can tell me? Anybody can tell me what's 3 to the power of 1?
3.
Just 3, okay. Very good. So you notice one thing is from 81, 27, 9, 3. All right, the next one they ask you, 3 to the power of 0. Okay. Anyone can tell me what's 3 to the power of 0?
1. Sorry, yeah, should be 1.
Should be 1. What about Jingyi? Do you know what is 3 to the power of 0?
Yeah, 1.
1 also. All right. So this gives you a 1. What about I give you a bigger number? 27 to the power of 0. What would that be?
It's still 1.
It's still 1. Okay, I give you much bigger number. 5,472. 5,472, I give you even bigger. Okay, that becomes 5,472,635. Wow. So that's a 5 million figure. Okay, to power 0, what would that become?
It's still 1 because it actually starts off as 1 multiplied. If there's a power of 1, it'll multiply by the number to give the same number. So 0 actually means that it's not multiplied by anything at all actually.
Okay, so it would just give you 1. So you see the power is very important now. Whatever things that you write, how big the number is, to power 0, that's 1. Okay, then I shall go on now. Do we have to the power minus 1? Let's say we have 3 to power minus 1. What would this be? Anyone can answer? It's alright if you say, I'm not sure.
I have
Okay,
no
just give it.
idea.
Okay, that's great. Xingyi?
I haven't been taught yet.
All right, good. Okay, anyway, there's a name for this. You call it reciprocal. Okay, what is the meaning of reciprocal? Means when you have 3 to the power minus 1, you can express it as 1 over 3 to the power 1. So whenever you have a minus, you actually put a 1 on top. Okay, so that gives you, of course, 1/3. Yeah, of course, 1/3 you will know is 0.3333, which is actually less than 1. Okay, okay, let's admit one more person. Okay, hi, Ting Xuan, can you hear me? Hi, Ting Xuan, can you hear Mr. Cole? Great. Okay, can you say hi to everyone?
I
Okay, I've just touched on, not touched on much. We are just talking about index notation. So I'm actually talking about 3 to the power minus 1, which is a 1/3. Okay, so once you have this idea of what is a reciprocal, or whenever there's a minus to the power of something, then you will just put on top. So I'm going to repeat this for two more. Let's say 3 to the power minus 2. Okay, so basically 3 to the power minus 2 will be just 1 over 3 squared. So that gives you 1/9. And then, of course, 3 to the power minus 3. Okay, so nothing so scary. We just have a minus, so we just put 1 on top, and then 3 to the power 3, or 3 cubed. And that gives you 1 over 7. So you notice one thing is the number has gone downwards already, becomes a fraction, becomes a denominator. So when the denominator gets bigger, the number gets smaller. Okay, is that all right? Okay, so that's something that you learn about for index notation. Yes, the teacher hasn't taught you, so this will be extra knowledge for you to begin with. Now we go on to the next one. Okay, so quickly, Mr. Ko talk about prime factorization and for finding the HCF, and then using the ladder method as well. So later on, you will see whether which one will you prefer, whether you prefer using the ladder method or using the prime factorization. All right, so let me just quickly do the maybe ladder method. Okay, so if it's ladder method, I will put side by side 154, 182, 406. So prime factorization, I don't know how comfortable you are. For ladder method, you just take out the prime 2, then you're going to repeat a few. So let's say 7 times 2, 14, 7 times 2, 14, 9 times 2, 18, 91. That's 2 and 0 and 3. Now, one way to check whether what would this be divisible by? Can this be divided by 3? Okay, not possible because the digit sum, in this case 14, cannot divide by 3. 91 also cannot divide by 3. 5 also cannot divide by 3. So I'm checking the digit sum. So of course 3 is not, then 4, 5, 6, 7. Okay, 7. In fact, the first number 77 gives me a clue that, okay, probably 7 is the next factor. So that gives me 11. So 1 times 7, 3 times 7, 21. So this will be 2, 7, 14, 9, 7, 63. All right, so I'm left with all the prime numbers, 11, 13, and 29. So therefore, the HCF will be just simply 2 times 7, which is 14. Okay, so let me just quickly run through how I can do it for prime factorization then for method 1. So similarly, prime factorization, what I'll do is I will just take 154 will be equal to, so 2 multiplied by 7 multiplied by 11. Okay, similarly, 182 will be just 2 multiplied by 7 multiplied by 13. And then lastly, 406 will be just 2 multiplied by 7 multiplied by 29. So for highest common factor, you have to check whether the common factor is found on all the 3 numbers. So in this case, 2 is found. In this case, 7 is. So therefore, it's just 2 times 7. And then that gives you 14. Okay, is this all right? Simple enough for everyone? Yeah, and not okay? Jingyi, all right? Jing Xuan, are you okay? All right. Is it new to you, Jing Xuan, about finding HCF using prime factorization and ladder method?
Yes.
Oh, so have teachers started your math lessons already in school?
No.
Teachers started prime numbers already?
No.
Not yet. Haven't started yet. So you're
No.
still having holiday.
We're having orientation.
Oh, wow. Okay, so 2 weeks orientation. Jingyi's orientation over already.
It was just over, but before the camp, we had 1 lesson of math.
I see. All right. So I hope Mr. Koh is not going too fast. If anytime you find I'm going too fast, you just let me know, okay? So straight away, I already jump into 3 numbers because 2 numbers, I think primary school, you did the 2 numbers before. All right. So I go on to 3 numbers straight. So HCF for 3 numbers, I'm going on to LCM already. So let's go on and look at LCM. How is it done? Okay, so this is the solution of what I did just now. Okay, so now we go on to LCM. So same thing, LCM 12, 18, and 63. So this is not too difficult a number given compared to just now the HCF. So what I can do is, okay, the LCM, I can just do prime factorization first. But before I do a prime factorization, maybe I'll do some branching. So I think you also learn branching in primary school. So maybe this would be a good revision also. So branching starting from 12. So what is 12? So basically there will be 3 times 4. So again, I branch down 2 times 2. So there will be 3 times 2 times 2. So all these are prime numbers. So I go on to 18. 18 will be 6 times 3. So 6, I leave it to 2 times 3. So I bring down the times 3. So 18 will be 2 times 3 times 3. Okay. So now